Hello students, in today's lecture we are going to discuss about the angular momentum of a rotating body. We have to determine the expression for angular momentum of a rotating body. So we have to consider a rotating, that is the rigid body. Suppose this is the rigid body that rotating about an axis passing through, that is the point O. So this is the axis of rotation for this rigid body having the angular velocity, that is the omega. The body consists of, that is the n number of particles, and the total mass of the body is suppose capital M. But before we are going to discuss about the angular momentum, what is mean by the linear momentum? Linear momentum. We know that linear momentum, it is indicated by using the letter, that is the capital P. Suppose this is the object having the mass, that is the m, and it is moving in this direction with velocity, that is the v. Then what is its linear momentum? So in case of translational motion, the object is moving along the straight line path. Then you can say that the linear momentum, that is P equals to, that is m into, that is the v, mass into velocity. So linear momentum, it is the vector quantity. We can represent like this: P vector equals to m into, that is the v vector. So this is for the linear momentum. In case of translational motion, it is the product of mass into velocity. And what is the SI unit for momentum? That is mass, it is kilogram, and velocity, it is the meter per second. So kilogram meter per second, it is the SI unit for the linear momentum. Okay. But we have to discuss about the angular momentum. Now suppose this particle, it is moving in a circular path like this. This object or that body, that is performing the circular path or the circular motion, and suppose this is the center for this circular track. Then this r vector, that gives the position vector for the object which is moving along the circular track. Now we can determine the angular momentum. So linear momentum in case of in translational motion, angular momentum when the object is performing the circular motion, then you can say that that momentum, it is the angular momentum, because when the object is moving along the circular track, then that object can describe the angle at the center. So at a particular instant when the object, it is at this position, then this r vector, that gives the position of that particle. After some time the object, it is at this position, then r vector, that gives the position of that particle along that circular track. Now the object is describing the angle, that is the theta. So in this case, in case of the circular motion, we can say that the object, it is having the angular momentum. Then what is the angular momentum? Angular, that is the momentum, it is indicated by using the letter, that is the L, and angular momentum, it is nothing but the moment of linear momentum. It is defined like this: it is the moment of linear, that is the momentum, that is called the angular momentum. That means we can write like this: angular momentum, that is L vector, is equals to, what is the linear momentum for this object? That is the P vector. And so when the particle at this position, then this is the linear momentum for that particle, and this r vector, that gives the position. So you can say that L vector, it is equals to r vector cross, that is the P vector. That means the moment of linear momentum, that is the angular momentum. So this is the angular momentum. So if we determine the magnitude for the angular momentum, then we can write like this: that is L equals to P r, that is the sine theta. And we know that the angle, that is the theta, between this r vector and this is the p vector, that is the 90 degree. So sine 90 degree, that is equals to 1, and therefore L equals to, we get, that is the p into r. But we know that p, it is in magnitude, linear momentum, that is p equals to m into v, and therefore angular momentum equals to m into v into r. So in case of magnitude, the angular momentum, it is given by, that is m v into, that is the r. But now we have to determine the angular momentum of this rotating object or the rotating body. Again, for that purpose, we have to consider the particles within the body. Suppose these are the particles at perpendicular distances, that is r1, then it is at distance r2, then it is at distance, suppose r3, up to, that is the rn. So these are the perpendicular distances for the particles. Then this, that is the p1 vector, p2 vector, p3 vector, up to, that is the pn vector, that describe the linear momentum for all the particles. Okay. Now for calculating the angular momentum, first of all we have to calculate the linear momentum for all these particles, then we can determine the angular momentum. Okay. So first of all we have to determine the linear momentum, then angular momentum for this particle, and then we have to add up all the angular momentum of these all particles, then you get the total angular momentum. So for the first particle, the object consists of n number of particles. So for the first particle, that is at perpendicular distance of r1 and having the linear momentum, that is the p1 vector, that is the angular momentum for the first particle. So angular momentum for, that is the first particle, that is given by L1 equals to, that is, what is the mass for this particle? First particle m1, m2, that is m3 and mn, these are the masses for all the n number of particles. So L1, so we can use this formula, we can determine the angular momentum for the first particle, and that is L1 equals to m1, it is the mass for first particle, v1, it is the linear velocity, that is along the direction of, that is the linear momentum one. So v1, it is the linear velocity for the first particle, v2, then v3, up to, that is the vn, these are the linear velocities for the particles. So m1 v1, that is into r1. But we know that, but v equals to r into omega, this is the relation for the linear velocity, that gives the relation between linear velocity and angular velocity, v equals r into omega, and therefore for the first particle v1 equals to r1 into omega. Now substituting this value of v1 in this relation, we get, that is L1 equals to m1, that is r1 omega into, that is the r1. So r1 into r1, we get L1 equals to m1 r1 square omega, and this is the angular momentum for this first particle. Similarly, the angular momentum for the second particle, that is L2 equals to mass of second particle m2, its perpendicular distance from the axis of rotation, that is r2, its square into omega. Then for the third particle L3 equals to m3 r3 square omega. Now similarly we can determine the angular momentum for nth particle. So Ln equals to mn rn square omega. So this is the angular momentum for all the particles within the body. Okay. Now from this we can determine the total angular momentum. So the total, that is the angular momentum, and it is given by, that is L equals to L1 plus L2 plus up to, that is the Ln. So we get, that is L equals to, what is the value for L1? That is m1 r1 square omega plus m2 r2 square omega plus up to that is mn rn square omega. This is the equation number 5th. Now on taking the common, that is the angular velocity omega, we get this one m1 r1 square plus m2 r2 square plus up to that is the mn rn square in bracket, and that is the omega. But we know that this m1 r1 square plus m2 r2 square, that is nothing but the summation of mi ri square, I equals to 1 up to the n, and this is the moment of inertia. And by using this we can write like this, L equals to I into omega, and this is the relation for, that is the angular momentum for rotating object or the body. Then what is the SI unit for the angular momentum? So we have the formula, that is m into v into r. So we can write the SI unit and dimensions for the angular momentum. So what is the SI unit? So SI unit for angular momentum, it is mass, that is the kilogram, velocity meter per second, r, that is the distance, meter. So kilogram meter square per second, it is the SI unit for the angular momentum. And what are the dimensions for the angular momentum? That is in square bracket we can write like this, kilogram, that is m1, meter square, that is means L2, and t minus 1. So these are the dimensions for angular momentum. By using this relation also, that is the moment of inertia into angular, that is the velocity, we can determine the dimensions. We know that